Hi class, today we're going to be talking about decision-making structures in C#. This is our Chapter 5 content. We won't be looking at the Chapter 5 presentation from the textbook, but I expect you to look through that on your own to see if there's any material you'd like to add to your notes. Your notes in OneNote should be being updated, and I know that when you're listening to the presentation, it's a great time for you to be updating your OneNote notes and getting all organized and finding additional images or creating drawings or whatever is meaningful to you, because OneNote will let you do all those great things. I won't be jumping back and forth, however, to do that, because I'll leave that to you. Now, when we're working in programming, decision making is a really critical part of our programming role. All of our logic is based on decisions, based on the state that our data is in, and the state that our data is in can allow us to control the flow of our programming code. So we can execute certain statements if a certain condition is true, and execute other pieces of code if a condition is not true. So that's why we call these selection statements, because they allow us to select which code is executed based on a condition. Here I have a cone of balls, and I'm looking for the violet ball. That's the one the baby likes. So if I had an if statement, if color equals violet, I would only get a true condition from one of those balls, right? The other balls wouldn't be impacted at all by my checking to see what color they are. I wouldn't do anything with them. But if in my if statement I was going to select that ball and take it out of the cone, then it would be impacted because it would be moved. This is an example of single selection. I'm only going to do something if the ball matches the color, if the condition is true. Here's the syntax of a C# if statement. This if statement is a single selection. It's only going to do anything if a given condition is true. So we start out with the keyword if, and it is lowercase. And after the keyword if, we have our conditional expression, our test condition. And that conditional expression is enclosed within parentheses. After our expression, we have an opening curly brace, and then we have lines of code that comprise our if statement body. Those are regular lines of C# code. You're going to have semicolons at the end of them, do all the normal things that C# code does. And then at the end of all of those lines of code, we're going to have a closing curly brace that indicates the closing of our if statement body. So we can do whatever code we need to if that condition is true. We have an alternative syntax, which allows us to eliminate the opening and closing curly braces if we only have one statement, one line of code in our if statement body. Along those same lines, if we only have one line of code in our if statement body, we can actually put that line of code on the same line as our if statement. Highly discouraged, but it is possible. Now, when we're thinking about our if statement condition, we want to think about something that always results in a Boolean, either a true condition or a false condition. So our test expression, our conditional expression, is something that we can say, yes, this is true, or yes, this is false. There's no shades of gray. When we're building our test condition, we can use the relational operators to compare variables or values to one another. So we can say, is this less than that, or less than or equal to that? Is this greater than or equal to that? Is it equal to that or not equal to that? So those are our options. When we're building our test condition, in general, it has to have two sides. So we'll have a left operand, and then some sort of comparison operator, and then a right operand. Now, our two operands could be variables, like is x greater than z, and our operands could be literal values. So we could check to see if the answer is equal to 42. That equal sign is one of our equality operators. The other equality operator is the not equal. In this code snippet, we're checking to see if the stoplight is equal to red, and if it is, we're going to stop. Here's that logic visually in a flowchart. We start out our program, we input the stoplight color, we check to see, is the light red? If it is, we stop. Remember, our equality operator is two equal signs in C#, so that tests for an equal condition. And we only execute some sort of code, our if statement body, if that condition is true. So we want to be really careful with those equal signs, because if we just used one, we would be using the assignment operator and we would just set the stoplight variable equal to red, and that's not what we would want to accomplish here. We want to result in a true or false condition. Now, when we're working with equality, the order of our operands doesn't really matter. So the if statement, if stoplight equal red, is the same as if red equals stoplight. It might be a little backwards to us, but it results in the same conditional test condition. So one is better than the other, though. The second one seems kind of awkward to us because we are used to reading left to right. And so to our brain, it makes logical sense to have the variable name first, and after the conditional or the equality test, the thing that we're wanting to test against. So whenever we're working with a value like that in an if statement, we want it to be the value to be after the expression, the conditional operator. So many big words. So if stoplight equals red is better for us than if red equals stoplight. We like it that way. Now, when we're working with conditional expressions, we want to make sure that we properly test our programs. So we want to use all the different test data that makes sure and tests out all of our different possible conditions. For example, in our little program, we'd want to test with red to make sure that we got a true. We'd want to test with yellow to make sure that we got a false. We'd want to test with purple. What are we going to do there? Make sure, well, I don't know. We're not going to get anything, huh? And our test data really needs to test out all these conditions. And as you can see, we might duplicate some of those values so that we make sure we're getting consistent results. We can't just test it once and be done. Now, sometimes we don't have things that are equal. Sometimes we need to test relationships of unequal values. So we can use the inequality operators, like greater than or equal to, less than or equal to. Our visual here says we're going to start a program and input the age. If the age is greater than or equal to 18, we're going to say that person is eligible to vote. That used that greater than or equal operator. Now let's look at a if statement in review of our syntax here. The keyword is if. The if statement body is enclosed within curly braces. The conditional expression is enclosed within parentheses, and there is no semicolon in the if statement. Okay, it's a block statement. It has a whole block of code. That if statement, when we only have the if keyword, is a single alternative or one-way selection. It only gave us one alternative. We only did something if the stoplight was red. We only execute that if statement body if the condition is true, and that's all. So we didn't do anything else. We didn't care what other color it was. Only if it's red, we're going to stop. That's all we cared about. So that single alternative only tested for one condition. Sometimes we need things to do alternative things, so we need a dual alternative or a two-way selection statement. We can do that really easy by adding an else clause to an if statement. So our syntax is our standard if statement followed by the keyword else. The keyword else then has opening and closing curly braces, that enclose its body all of the code that will be executed if the else statement is chosen to be executed. And how does the else statement get chosen to be executed? By the if statement resulting in a false condition. So if my if statement results in a true condition, my if statement body is going to get executed. Otherwise, my else statement body is going to get executed. Just like previously, I can eliminate curly braces if I only have one line of code in the code body, and I can put everything on one line if I want the programming gods to keep me up nights sweating and worrying about how I'm coding. Now, it can also get really confusing because we can mix and match. So I could have an if statement that had opening and closing curly braces delineating its body, and I could have an else clause that doesn't. So be aware of what your code is going to look like to others who have to work with it. When we're working with a dual alternative, again, we only have two alternatives. So in our case here, this visual example, if the age is greater than or equal to 18, if that's true, they're eligible to vote. If it's not true, they're not eligible. So we don't really have any other alternatives here. We have either the yes path, it's true, or the no path, it's false. What if we need multiple alternatives? With C#, we have really a couple of options, and the preferred option, if possible, depending on the data we're working with, is to use the else-if clause. And the else-if clause gives us the ability to check for multiple alternatives. So the syntax, I'm looking over here at this right code block, is our standard if statement with a conditional expression, and then the keywords else, if. Now, because I've used the keyword if again, I have to have another conditional expression enclosed in parentheses. If that condition evaluates to true, the code within my body will execute. So I have opening and closing curly braces to delineate that code. I can follow that again with another else if clause with a conditional expression. Anytime I have the keyword if, I have to have that conditional expression. I can have as many else if clauses as I like. At the end, if I like, I can have a final else clause, and this final else clause is the code that would execute if none of the previous conditions were found to be true. This example over here shows the else if without curly braces, and we just can't fit it all on one line, but we could put else if and all that on one. Okay, so this is a visual for multiple selection that we were just talking about. I'm going to input the age. If the age is greater than or equal to 21, I'm going to say they can drive, vote, and drink, not at the same time, right? But if it's not, I'm going to check to see if the age is greater than or equal to 18. And if it is, I'm going to say, oh, they can drive and vote. But if it's not, I'm going to check to see if the age is greater than or equal to 16. If it is, I'm going to say, oh, they can drive. But if it's not, I'm going to say, sorry, that's just too young. And then we'll be done. So here is that in code. Over on the right, I have the else if clauses. I hope that's the right to you. It might be reversed. This smaller code block. And in this code block, you can see we use if statements and else if. So if the age is greater than 21, we're going to output this line. Else, if the age is greater than 18, we'll output this line. And we just continue on in our nice structure until we hit our final else clause to output the message. Sorry, too young. Nice and clean. Now this other code shows a nested if structure. And a nested if structure is fine and perfectly legal. And a nested if structure is where we have an if statement as part of another if statement body or as part of an else clause body. And nested if statements are very useful and used often. But if we're in a situation where we're repeatedly checking the same variable over and over, our code could be much clearer if we use the else if clause instead of nested if statements. Let's take a look at this example and you should see what I mean. Here we check to see if the age is greater than or equal to 21. Same start, right? If so, we write out this message. Then we have an else clause. Now our else clause has opening and closing curly braces because we want all of the code within this else body to only be executed when the else statement is chosen to be executed. So then inside the else clause, we say if the age is greater than or equal to 18, we output this message. But if it's not, we have a new else clause, again with opening and closing curly braces. And notice the further apart the closing curly braces are from the opening, the more complex our code is, right? It's kind of harder to figure out. Within that else clause, we have another nested if else to check to see if they're old enough to drive or not. So this code is much harder to understand and update than this code. So we want to make sure that we're using the more maintainable version. We have another code structure that's available in C# for multiple selection called a switch or switch case. This is actually a more efficient to process structure than an if-else-if structure is. We have a switch statement at the top that identifies a variable. Then inside the opening and closing curly braces of the switch statement, we have multiple case statements. The case statements identify a specific value that we want compared to that variable's value. If they result in an equal comparison, we'll execute the case body. The case body will end with the break statement, which will break out of the case statement, causing it to be done. Each of our case statements is kind of a single thing. Only one of them is going to be executed, kind of like that else if previously. If none of the case statements are found to be true, the default clause will be executed if a default clause exists. Here's an example. Now we have a couple of examples here so that you can see how this works out with some different data types. First of all, over on the right, the larger example, we have our age test. So we're using the keyword switch, and then our variable expression within the parentheses is age. Age is the variable we would like you to test. Our first case statement says, I want to check the case of 21 to 150. Well, that's a range check. So I'm basically saying if the age is 21, 22, 23, 24, any number between 21 and 150, including 21 and 150, I want to do this thing. Output this message that they can do everything they want. Notice that to get this to work with the case statement, I had to just come up with an arbitrary number that should be greater than the maximum age, right? So that, because I can't use that relational operator in this case condition, I can't put greater than 21. So I have to have a specific value or range of values. So then my next case clause says, well, if they're from 18 to 20 inclusive, write out this line, then break. If they're 16 or 17, write out this line and break. Otherwise, tell them they're too young. Now, this switch case statement can take a second or two to get used to, but it's a really efficient structure. The processor can handle it very well in a very quick manner, so that's why it's considered more efficient internally. This switch statement gives you an example of working with a string value. Here we have our stoplight example, and we're using that stoplight variable in our switch statement. So we want the switch on stoplight. And in the case stoplight is green, we want to write out this line and break out of our case statement. In case it's yellow, we want to slow down, brake. In case it's red, stop and brake. And then our default here would actually check for that purple value and say there's a traffic light malfunction. So we've got an opportunity to cover all of our different bases here. So switch case, really, really effective. Something that you want to get familiar with and feel comfortable with. Now we have one last weirdo type of conditional expression, and that's the ternary condition. And the ternary selection involves a selection with three parts, basically. First of all, we have the condition, and then we have the true action, and then we have the false action. So all three of these things are all put together in one statement, making it the ternary type statement. Here's an example. It's not any different than the others we've looked at. We want to check to see if the sun is shining. If the sun is shining, we're going to go fishing. If the sun is not shining, we're just going to hang in the cabin. So let's see how we can fix that. First of all, over on this side, I have it in an if statement. Our sun shining variable is a Boolean, and it's been set to a true value. So our condition is nice and short because we have this Boolean that's being our left operator and our right operator, and it's already got a value of true or false. So we don't need anything more to our conditional than it's Boolean. So if the sun is shining, we're going to write the line, go fishing. Otherwise, we're going to write the line, hang in cabin. Yeah, I don't like that kind of code, but it works. It's effective. It's very short. It's compact. So we can see what's happening there pretty easily. We might actually be able to see what's happening there easier than with the ternary operator. But the ternary operator compresses everything down into one line. Now in my ternary operator, I should not have this go fishing string here because I want the output to be the same. But let's just say that we're going to have the go fishing question mark, and then after that we're going to follow it with our message. So our message then is going to be our parameter that replaces this parameter in our right line statement in our format. So I've got my condition in parentheses. Is the sun shining? Then I have a question mark, which is a special character that's required, and it says what follows is what should happen if the condition is true. So if the condition is true, I want to replace this parameter with the value go fishing. Then I have a colon, and the colon represents the position that what follows me is false. So if the sun is not shining, I will use hang in cabin to replace that parameter. So depending on the sun shining variable, I'll either plop go fishing into my parameter, or I will plop hang in cabin into my parameter. Super powerful. I've seen some students do some amazing things with some ternary operators. Notice this doesn't have to be in a right line. It could be in any sort of statement where I wanted to get yes or no or whatever kind of value that I wanted. I could actually have this set up where I called a method depending on the outcome of this ternary statement. So really, really powerful. Now, all of our expressions so far, our test expressions, have been simple expressions, but we can make them compound by adding multiple test conditions together. So we have the and the or operators, logical operators, that we can use to combine those things. Notice we can use one pipe character and one ampersand character, or two. Now the pipe character is above your enter key, so it's shift backslash. If you've not used it before, that's what that is. Now a logical and a logical or will cause the processor to evaluate both sides of the condition. We'll see what I mean here in a minute. And a conditional will allow a short circuit. Our last operators, of course, are the question mark colons from our conditional ternary. Now let's look at some of these range checks, and as we do, we'll talk about the short circuiting. First of all, let's look at this AND clause. Because I've used the short circuit operator, if the first half of this condition results in a true condition, or I'm sorry, a false condition, the second half of it will not be evaluated. Because if the first half is false and it's an and, we know the whole thing is going to be false, right? Because if this half is true and this half is true, our overall condition is true. But when we're using an and operator, if one side is false, the whole thing will be determined false. So that's what the short circuit does. It says, well, if this first half is false, there is no need to waste the processor time evaluating that second half. We're done. Short circuit. No need to check. It's false. Now, in an OR condition, conversely, like we have here, if the first half of this OR condition is true, we're going to short circuit and not evaluate the other half. Because since it's an OR, if half of it's true, the whole thing is true, there's no reason for us to waste that processing power to evaluate the other half. Now, looking at these particular examples, there's a problem with each of them. So I want you to think about what that is. What about this first one? It's got red squiggly, so we know it's even a syntax error. It's so bad. Didn't used to be. Thank goodness it is now. In this first one, the programmer is trying to check to see if the age is equal to 14 or 15. And I know that, and you know that, but C# doesn't know that, or doesn't want to know that, because they would be making too many assumptions. What if it wasn't? What if they wanted to check something else? So this example is incorrect because we need to have a left operand, a conditional, and a right operand on each side of our logical operator to make a complete condition. We can't just have this number 15 hanging out here in space. So to fix that, we would say if age equal 14 or age equal 15. That would be the correct syntax. What about this one with the stoplight? We've set the stoplight to green. We say if the stoplight equals green and the stoplight equals yellow, you may proceed, otherwise stop. Now, with the way this program is set up for our green light, it's going to say stop. Why is that? We've got an improper and here. We can't have the stoplight equal green and the stoplight equal yellow at the same time. It's an impossible condition, so it's a logic error. So we would never get a true condition out of this if statement. There's no syntax error. There's nothing wrong with the syntax. It's perfectly fine. We can mess up everything we want as long as we do it within the right syntax. But this would cause a logic error. We would never get a you may proceed message. We would always be told to stop. So this should be an or condition. The one in the middle. We start out if age greater than or equal to 16, you can drive. Else if age greater than or equal to 18, you can drive and vote. Else if age greater than or equal to 21, you can drive. Blah, blah, blah. All those things. Otherwise, they're too young. What's wrong with that? Again, it's a logic error. For our 14-year-old up there, they would come out too young. So our test data would not show us this logic error. What's the logic error? What if our age is 21? What message are we going to get? Is 21 greater than or equal to 16? Yes, it is. So we're going to get the message, can drive, and that's going to be it. That's going to be done because it met one of the equal conditions. It goes right to the end of the if statement when that equal condition is done executing the if statement body. So that would be wrong. What we should do there is check, since we're doing a greater than condition, we should check for the highest value first. So if it's greater than 21, we'd get all those people. Else if it's greater than 18. So this is a logic error because we're using a greater than, but we're checking the smallest possible value first. What about this last one? Here we're saying if the age is greater than or equal to 18 or less than or equal to 21, they can drink, drive, and vote. If it's greater than 18 and less than 21, they can drive and vote. I don't know why I've got that twice. That would be an error. If it's greater than 16 and less than 18, they can drive. Now, besides that error of having that duplication, what is wrong with this one? Let's try our test data at age 14. Is 14 greater than or equal to 18? No. Is 14 less than or equal to 21? Yes, it is. So we would write out this message, can drink, drive, and vote for the 14-year-old. That doesn't seem quite right, does it? That's because with the range check, like this, we need this to be an and condition. So we're checking to make sure that both sides of this if condition are true. The age is greater than 18 and less than or equal to 21. So we want to make sure that we're doing our range checking properly. So those are some good examples of some conditional expressions that can compile properly and look great and give us the improper results. A truth table is one way that we could find these sort of things. We can write down the different values of our variables, and we can use that to compare to our actual test data, and then check to see what would happen if we had an and condition and an or condition. So for example, if I have the test data of green as a stoplight, my stoplight equal green condition would be true. My stoplight equal yellow condition would be false. If I combine those two conditions with an and, I would come out with a false. If I combine those two conditions with an or, I would come out with a true. Now, if my stoplight were yellow, this first thing would be false, yellow would be true, and would still be false, and or would still be true. So looking at this, no matter what, I can never get a true result out with that and that I accidentally put in there to combine those two conditions. So we have to be super careful about those logical operators. Our order of operations can also affect the way things work. If we try to get really, really complicated and do all sorts of work inside of our conditional statement, unary operators are performed first. Those are addition and subtraction values that apply to one variable, like plus, plus, minus, minus, those sorts of things, and a simple not operator. Then multiplicative, which would include dividing, add and subtract operations that are more than one operator, our relationals, greater than, less than, our equality comparators, our logical and or, our conditional and or, our conditional ternary, and lastly, our assignment statements. So remember, always use parentheses to clean things up and make sure things that happen in the right order. Even if your order of operations would be correct, it's nice to use parentheses to document that. So overall, decision making is at the heart of programming. We really need to know how to make these decisions. We use it to control the program flow based on our variable data and conditions. Decision making structures in C# are the if else, if else, if else, switch, and ternary. Quite a few. Create practice programs like those shown in the presentation to work with different data types, values, and conditions. You have Rebel to use, you have Visual Studio to use. Try things, experiment with things. When you get unexpected results, make sure you can explain why, because that's an important part of the learning process. So let's have some fun with some conditionals. Thank you.